You know those magic tricks that turn out to be just pure science? Well, today we're diving into a physics concept that feels exactly like that. We're going to figure out how to give an object a real, honest-to-goodness electrical charge without ever actually touching it. Let's get into it. It sounds kind of impossible, doesn't it? I mean, we're all taught that electricity needs a path, some kind of contact to flow. But what if I told you that you could manipulate an object's charge just by getting close to it? That's exactly what we're about to explore. So the secret sauce here is a principle called electrostatic induction, and the key word is rearranging. It's not about zapping new charges into an object, it's about shuffling around the ones that are already there. Think of it like using an invisible force field to persuade an object's electrons to move from one side to the other. Okay, look, the best way to really wrap your head around this is to see it in action. So we're going to run a couple of little virtual experiments. First up, we've got a classic demonstration called the grounding trick, and it perfectly shows how this all works. For our little setup here, we need a metal sphere. That's our conductor, where electrons can roam around freely. We'll use a negatively charged rod as our tool to boss those electrons around. And the secret ingredient? A grounding path. A wire's great, but believe it or not, your own finger works just as well. All right, here we go. We bring that negatively charged rod close, but not touching the neutral sphere. And instantly, on a microscopic level, things get really interesting. See, since like charges repel, all those free-floating electrons inside the sphere get pushed as far away from that rod as they possibly can. This mass exodus leaves the side closest to the rod with a net positive charge. But here's the catch. If we pull the rod away right now, all those electrons that were huddled on the far side, they'll just rush back and spread out evenly. The sphere goes right back to being neutral. So the charges are separated, yeah, but they're still trapped. How do we give them a one-way ticket out of there? The solution is to give them that escape route. By touching the far side of the sphere, right where all those electrons are crowded together, we create a massive path to the Earth. You gotta remember, the Earth is so huge it can basically absorb an infinite number of these tiny electrons without even noticing. And that's exactly what happens. The electrons, still getting pushed away by that rod, see this brand new, wide-open highway, and they take it. Whoosh! They flow right off the sphere, down the wire or through your finger, and into the ground, leaving our sphere with a serious electron deficit. Now listen up, because the sequence here is absolutely critical. You have to remove the ground connection before you take the rod away. Why? Because if you move the rod first, those electrons you just got rid of will see their chance and just flow right back from the ground onto the sphere. By pulling your finger away first, you've slammed the door shut, trapping the sphere in its new positively charged state. And there you have it. We pull the rod away, and the positive charges that are left behind spread out evenly across the sphere. We have successfully given it a net positive charge, and we never once touched it with the original charged rod. Pretty cool, right? Okay, that was impressive. But what if we could do even more? In our second experiment, we're going to use the exact same principle, but this time we're going to create two oppositely charged objects from two that started out perfectly neutral. This setup for this one is even simpler. We just need two neutral metal spheres sitting side by side, touching each other. And, of course, our trusty negatively charged rod. When those spheres are touching, they basically act like one big, long conductor. So the process starts out pretty much the same. We bring that negative rod close, the electrons in the first sphere get repelled, but this time they don't just bunch up on the far side. They have a perfect escape route right next door, the second sphere, so they flee all the way over, packing themselves into sphere number 2. And right here, this is the key move. While that negative rod is still holding all those charges in their separated positions, we just pull the two spheres apart. This physically traps the excess electrons on that far sphere and leaves the near sphere with a deficit of electrons. Once they're separated, we can safely remove the rod. And look at that! We started with two totally neutral objects, and now we have one that's positively charged and one that's negatively charged. We've literally split the charge and created a pair of opposites, all thanks to the magic of induction. So, after those two simple but, really powerful experiments, what's the big takeaway here? What does induction really teach us about how all these electrical charges behave? It really just boils down to that one key action in the middle of the process. In our first experiment, we used grounding to give the electrons a permanent escape route, leaving us with one charged sphere. In the second, we used physical separation to trap the rearranged charges, creating two oppositely charged spheres. And this really gets to the heart of it all. Induction is fundamentally different from conduction, which is what happens when you charge something by direct touch. Conduction is a transfer of charge. Induction is just a rearrangement. And here's the dead giveaway. With induction, the object always ends up with the opposite charge of the tool you used. We used a negative rod to create a positive sphere. That's how you know induction was the name of the game. And that leaves us with a final thought to chew on. We just saw how a tiny charged-up plastic rod can totally manipulate the charges in an object just by being nearby. So just think about this for a second. What are the massive, powerful electric fields generated by thunderstorms or power lines or even the Earth itself doing to the charges inside you and all around you right this very moment? It's this subtle, invisible dance happening everywhere, all the time.